Hi, in this presentation we are going to demonstrate our knowledge graph and platform for European public procurement data. Public procurement basically concerns government purchase of services, works and supplies, and it makes up a very large market. Therefore, availability of high quality data ensures efficiency, transparency and accountability. To this end, we developed a platform for integrating and ingesting data from two main data providers. OpenOps provides procurement data it gathered from distributed data sources, such as national portals. OpenCorpBase provides company data it gathered from national registries. Data is stored in a triple store, associated with the relevant documents through a document store, linked to original data sources, and made available through a SPARQL API, REST-based API, and so on. We are going to demonstrate the knowledge graph provisioning process in terms of data ingestion and data publication, and advanced services that we built on top of the knowledge graph and platform, namely anomaly detection and cross-lingual search. Let's start with data ingestion. We implemented a daily routine for ingesting data. We first start by downloading procurement data from OpenOps. Then we match suppliers appearing in procurement data against companies provided by OpenCorporates and download matching companies. We enrich JSON data with identifiers and convert JSON files to XML due to limitations in JSON path. We map XML data to RDF based on two ontologies, one for representing company data and one for representing procurement data. We published RDF data to database. We provided some figures and the specification of the machine we have used in order to demonstrate the scalability of our approach. Python was used as the primary scripting language, RML mapper was used as the mapping tool, and finally Apache Genafuseki and TDB was used as the SPARQL engine and the triple store. As of September 2020, we have 1.29 million statements, 1.35 million tenders, 1.58 million awards, and 100,000 companies that are matched. Let's continue with data publication. The knowledge graph is primarily published through a SPARQL endpoint and the REST-based knowledge graph API. The knowledge graph API was built using the R4R tool and is based on velocity templates. Let's see some examples. In this screen, you see ISWC interface running on top of our SPARQL endpoint, and you see an example query. In this query, we are basically asking for all the organizations and their associated awards, along with the award amount, number of employees, and so on. This is basically for submitting ad hoc queries. And in this screen, you see the Swagger interface built on top of our REST-based API, the knowledge graph API. This is basically for non-semantic web developers to implement basic data access routines to the REST endpoint in an easy way. Concerning the anomaly detection, manually analyzing a large volume of procurement cases for detecting possible frauds is not feasible. Therefore, we applied several machine learning techniques on top of the Slovenian public procurement data in the knowledge graph to identify patterns and anomalies. In the screen, you see the platform that we have developed for this purpose. It uses supervised, unsupervised, and statistical approaches, such as decision tree and clustering. In the visual presentation, you see the interdependence between the tender value and the number of employees of a bidder. The curve shows normal linear behavior in the middle, but the deviating behavior on the top and the bottom corners. On the upper left corner, we can see the big companies with high number of employees that won small tenders. And on the bottom of the curve, we see the companies with small number of employees that won big tenders. We can further analyze these cases. For example, we can select a company. In this example, this company basically has only one employee, but won a very big tender, which amounts to 83.1 million euros. Not every anomaly necessarily needs to be a legal situation. For example, in this case, the company is a multinational company and only has one representative in the country. However, the whole system allows us to find such cases and further analyze them. Regarding the cross-lingual search, procurement documents are often published in different languages. We developed a service for finding similar documents independently of the language. The service is based on the use of unsupervised probabilistic topic models. Let's see an example. In this screen, you see an interface built on top of our cross-lingual search API. And there's an example query. In this query, I am asking for 10 tender documents in Spanish that are similar to this given English description. So I basically execute this and get 10 documents in Spanish that are similar to given English description. Finally, all the data and software artifacts mentioned in this demonstration are available online openly through a catalog. Thank you very much for your attention.